Good morning. My name is Marcus. I'm the Wells lead within the Shell OSDU program. And my partner in crime today is Randy Petit. He's the lead for our customer success team here in the Americas. Just a wee note from our sponsor. When you're finished reading, please just put your hand up and we'll continue. All right. But seriously, this is just Shell Legal informing you that anything that Randy and I say today shouldn't really be used as a predictor for future Shell business performance. Okay, so I'm going to set the scene today with where we're at with OSDU and Shell. We have 3 regional instances of OSDU in production with a supporting acceptance instance. We're using a managed service from AWS, EDI, or Energy Data Insights. And we've deployed our Wells Master Manager application and directional survey module to 6 countries to date. If you look at all the data that we've identified for ingesting into OSDU, we're currently at about 45% of our data is in OSDU today. I can't give you the numbers like we heard from Stan on Tuesday, but we do have a lot of data. It's really exciting and cool to be able to start bringing data together and visualizing it in our visualization environments. Yeah, so over in Asia Pac, we have WMM and OSDU deployed to our Malaysia asset. Our Europe instance of OSDU supports our assets in Oman, Netherlands, Norway, and the UK. And here in the Americas, we have an OSDU instance supporting our Gulf of America instance. And in addition to our WMM deployments, we have a large number of countries where our different teams are busy ingesting data into OSDU for all sorts of different data types in preparation for future well master manager deployments. Our value driver is quite simply to simplify and reduce cost. So, bring all our content together into one data platform. Protect our license to operate, leveraging the security features in OSDU. This is my favorite, smashing the silos. It's really exciting for us in Shell to bring data from our legacy data stores, bring it all together into one environment. This helps with our data interoperability and our ability to support multidisciplinary workflows. For those who are data ingesters, you get data into OSDU, you know that OSDU is a bit of a beast, right? The data's got to be super clean or it's not going in, right? So it's proven to be a really good data quality improvement drive with clean data going into OSDU that really helps with the use of that data in the platform. Of course, the big benefit is all our users and asset team members are no longer spending time collating and bringing the data together or just finding it. But of course, right from the get-go, they're able to use the data and perform their workflows. Of course, with OSDU, it's positioned for the future. It's cloud ready, or it's on the cloud, it's AI ready, and we can look forward to using lots of different market solutions on the platform, many of which are outside this room. Okay, so the application I'm going to be talking about today is a Well Master Manager, or WMM. It's an in-house workflow tool we've developed to enable mastership of our well, wellbore, and directional survey data. It was originally developed for SDU, our legacy platform. It's now been ported and deployed to our OSDU platform for the assets that we mentioned earlier. We had to build WMM simply because when we started SDU, there wasn't an application available, and we needed an app to be able to see the data that we're ingesting into the platform. The core requirements for WMM, though, is it supports one standard workflow across all our assets and discipline users. It obviously supports standard data definitions and a reference list with definitions. And most important for us, the WMM supports the use of the Shell Unique Well Identifier, or the Shell Unique Wellbore Identifier we affectionately refer to as SUIs and SUBIs. Okay, so I'm going to just a quick introduction about master data management. All corporations or entities will have a suite of master data types that they need to manage. In oil and gas, we'll have facilities, things like wells and wellbores. Those entities are all supported by rich schemas, some with reference lists. Master data management is the process in place for all the stakeholders to effectively manage their master data. For us, on OSDU, WMM is our solution for mastering our well, wellbore, and directional survey data on OSDU. So why is this important? Well, this is the multiple versions of the truth problem we've had in the past. Is that we've got a lot of systems managing well and wellbore data, different, usually managed by different disciplines, different standards to support different workflows. And getting that data to be consistent is a real problem. We've got pipelines in place and a spaghetti junction architecture to try to keep things aligned, but it's pretty difficult to keep those systems aligned. So for an asset that's trying to use all their data from all their stores, it's pretty tough, right? How do they collate that one version of the truth from the data? So we got business problems or even possibly safety problems for things like where do I create a planned well? Like what's the system am I going to use? If I have production volumes, which well and which system do we want to assign it to? Where is my well? We got different location coordinates managed in different systems, and they're not always consistent. What is the status of my well? Is it abandoned or suspended? And what do I tell my partners and regulators and other stakeholders about my well? Well, those are the problems we're trying to address with WMM on OSDU. So we developed the WMM application. OSDU supports one version of the truth, and it's used by all our disciplines using the same tool with the same process. So whether you're in technical data management, geomatics, or wells, you're using the same tool to manage the one version of all these records. So key features of the WMM application include a dynamic data dashboard, right? So when you launch WMM from our OSDU portal, users can see some quick analytics about the content in that particular OSDU instance. Of course, the core feature for WMM is the well and wellbore management, right? So you create wells and wellbores to get assigned a Shell UWI. And of course, folks can go back and edit our wells and wellbores. There's a search feature, right? So leveraging the search API. So it's pretty cool. You can just go in, type in something, and it'll produce a nice long list of wells or wellbores. And then you can refine that list further, filtering for things like life cycle state, country, operator, et cetera. When we developed the WMM application, we had some data quality requirements, right? So certain fields will have asterisks on them that indicate mandatory fields. And also, we had some data quality checks built into the workflow. So for example, when you're entering coordinates against a CRS, if those coordinates aren't within the bounds of that CRS, well, you're going to fail, right? Or in this example here, it's a pass. That pass is captured in the record. It also allows teams like our geomatics folks to capture their assurance content against these same records. Using the versioning capability in OSDU, we can see a full audit trail of all our records. Right, this is really useful when you've got discrepancies or arguments about why is a value the way it is. Well, you can go back, look through the versions and see where it was changed, who updated it, and when, and understand why the value is what it is. Of course, the WMM application supports OSDU security, so users go in, they're only able to see the data to which they're entitled. The WMM application also supports using the a user's ACL membership. It controls whether they're a read-only user or a read-write user, which would be for our technical data management users. Okay, so when we built WMM, we had a number of Mastership agreements about how data would be managed between WMM and feeder systems. So we had a number of desired states. So basically, we wanted all identifiers, names, numbers managed within the WMM application. We have, during certain phases of a well, during any well operation, there's data that's being fed from our well system into OSDU. So things like well status, life cycle state, and so on, they get changed by the well system and synced into OSDU. Wellbore status, though, is managed entirely within WMM. Of course, the WMM allows our data management community to apply metadata to our wells and wellbores, so things like fields, operators, blocks, et cetera. Also, during well construction, the assets wanted to see their well content in real time. All right, so when we're doing operations reporting, that data is flowing into OSDU and is updating the well and wellbore records for certain things like costs, dates, depths, vertical measurable elevations, and so on. The key requirement is we wanted our geomatics community to provide them with a tool that they could use to manage their location information. So coordinates, CRS, coordinate accuracy could all be captured one way globally by all our geomatics teams. The key requirement for WMM is it allows us to enforce a one standard process that's used by all our teams consistently for all our assets. Okay, Randy.
Thank you. So Marcus talked a lot about the technical aspects, the under-the-hood platform change, the benefits we received from that, and the technical deployment of the tool. But one thing that had to happen on our side was behavioral change, process change. We needed teams to move away from my data, my tool, my silo, into an integrated environment where change management was more important because now your change impacts users down the line. And we don't have different systems anymore in some cases to manage this different ways. So it required a lot of effort. We wanted one big sandbox, one castle being built. We didn't want different versions, right? We didn't want our user community using different values. Lots of commercial systems in Shell, lots of in-house systems. Attribute requirements are different. What attributes are actually mandatory are different in systems. We have production systems that only have producing wells. We have exploration tools that have all wells. We have development projects that just have development wells. And we don't really want to duplicate that data unless it's absolutely necessary. Well status, well life cycle state was a big thing. We also wanted to be able to run complex data quality queries, like if a life cycle state is set to abandon, obviously the status of the well can't be producing. So we wanted to implement that more robust system, and then also track the history. Marcus mentioned the versioning, the audit trail. Now we have a tool and a platform where we can actually, it's part of it, right? We don't have to build specific audit tables. It's part of the system. We were able to keep these things aligned before we had OSDU, but as you can see in the bottom left corner, a lot of it was done with massive amounts of ETLs and very reactive data quality queries. Someone changed something, we need to go fix it in the system. Now we're able to more effectively monitor just a smaller number of ETLs and check to make sure those are working properly and the data gets cascaded down into those systems. So we're really getting into that one user interface. With the WMM application, we've deployed minimum data requirements. So if something is not populated, it might not affect the tool in WMM, but it could affect something downstream in an ETL. So we wanted to make sure that not only the things that a user, so if Wells was starting the creation of the well, they put in the extra attributes that were needed downstream to support the other systems. So we've been able to integrate that into the tool. Another big example is well coordinates. Our geomatics department certifies, they assure coordinates. We have them review coordinates. We want that done at the right time. We have coordinates in various systems, different CRSs. We store coordinates in their original format as they were recorded and received, and then we often normalize them into something consistent like WGS84 for mapping. So we have a variety of systems, but we also needed a way to track the audit trail. Bert, who's here, big part of the geospatial consumption zone, we built some of those assurance tools into WMM so they can facilitate populating that content inside of OSDU. So we now have a system where the coordinates, the assurance process that's conducted by geomatics is done within the tool, and that audit trail, that information, those quality factors are saved, and then that data can move downstream. Then we can do things like generate wellbore paths. There's no controls in place in WMM. So I can change well values, I can change geomatics values. We control that with work instructions, working together. We have regular data quality reviews together to assess things, do root cause analysis when we have problems. But we are now all working in a single environment, which provides that single user interface and then one version of the truth to our customers. So big impact and big change, and we have more to do on the behavioral side and just the workflow side.
Thanks, Randy. All right, so to summarize, in Shell, we now have OSDU and WMDS deployed across several Shell assets, blending and integrating data from several legacy systems. With OSDU, we now have one source of the truth for all our users and consuming systems, bringing disciplines together into one system of record and engagement. With WMM, it supports simplified standard workflows supported using a common nomenclature. That's really important so that when different disciplines start talking about their well and wellbores, they're all talking with the same language. With WMM on OSDU allows us to realize our master data management ambition for wellbore and directional survey data. So with OSDU, we have one standard global system, and it's a gateway to automation and further OSDU opportunities and deployments. Thank you.
Okay, thank you very much. Please show your appreciation for the presentation. Thank you. So we do have time for questions. Okay, I'll make my way over there. 1 second, please.
Thank you. Kristen Sullivan with BP. How do you handle the well planning process? For example, if you're considering multiple surface holes or combination of targets, how do you handle that?
At the moment, we haven't really focused. I know BP's been really focused on the well planning workflows in OSDU. We're not there yet. We're more focused on managing our actual well data and getting all that content into OSDU. We have some plans for implementing well planning workflows, but we haven't put it in there. So one simple thing is with WMM, you create a proposed well, and for a long time, a proposed well will be just something that ends up on the rig schedule, and then over time, the data gets added, or plan data gets added to that well. So that record might have plan coordinates and elevations for a period of time, but when things firm up, the rig spuds the well, that it becomes actuals data. So we have this thing we're looking at called opportunity wells, where you're looking at multiple flavors of something that might become a well. But we haven't adopted that yet in our OSDU workflow. Yeah.
Thank you.
Thank you. Okay, over here. We have a few questions on this side.
Hi, Vijay from GeoSoftware. Thanks for the presentation. I have one question. You said 45% of the wells, subsurface well data has been migrated into OSDU. That means there's the other 55% which is still in already mature data systems. So
are you?
No, I'm not done yet. My question is, let's say you're working in some region. Is it either all the wells from one region are in one system? And if not, how do you manage working with wells that are in OSDU and wells that are not in OSDU?
Okay, you're kind of talking to our deployment strategy. This past year, we kind of pivoted on our strategy of how we deploy OSDU. So we're focusing essentially one asset at a time, right? So when we're ready to deploy an asset, we're basically, all the source systems, the data is fed into OSDU for that asset. So there isn't any issue of missing wells or partial content. It's all content goes in for that asset deployment.
Yeah, and I could add to that. So we're also testing EDS. So we have successfully tested EDS with one of our vendors to bring in not public well data, but commercial well data set. So for most of our deployments, what's in WMM or wells we manage, our operated wells, and then sometimes where we're partners and non-operated, where we have the data and information to manually take care of that, and we don't have a market solution that's as rich, right? But we do still leverage public data sets in a lot of countries, and we also leverage commercial third-party data sets from vendors.
All right, one more question. It's actually two questions in one. I don't know if you can see me. Maybe I need to stand up, actually.
Yeah, we can see.
So do you enter metadata for the wellbores and master them on the fly as well? Because that was kind of my understanding from how you described it, Marcus.
Well, I
And
mean,
if that was the case, how do you manage the entitlements between the users that enter the data, considering that obviously you have hundreds of thousands of wells regionally, and when you do the quality checks and mastering and auditing the wellbore changes to create that golden record at the end in OSDU? Is that really on the fly, or do you do that prior, and how do you manage the entitlements?
Well, this is what Randy's customer success team does. Randy's team, there's a few of them in the audience today, but it's Randy's team members who will be using WMM to manage our data. But to answer your question, essentially, for Shell-operated wells, it's going to be done on the fly, with some inputs from some feeder systems, examples from wells.
Yeah, and data shows up over time. We have different disciplines and different teams working in the tool. So minimal attributes at the beginning. As the well is drilled, the well is completed. We have a final depth. Those get certified in the tool. Once Geomatics has the coordinates, the surveys, they do a certification of the coordinates. That's put in the tool, and there are downstream things that happen. Again, part of it is leveraging EDS in the future for bringing in large groups of wells from third-party vendors. We have our current legacy system. We do a lot of ETL and loading of that public data sets from either vendors or public sources, and we have historically tried to take care of all of that. That's a pretty impossible task, so we're looking to leverage more OSDU technology like EDS and use what's available and not have to take care of that ourselves. Where we don't have someone, those wells would not show up in this GUI. They would be excluded so that they can't be changed and edited there.
So we have 5 minutes left. I think there's a couple more questions. Thank you.
Glenn Edwards, BP. You may have just partly answered this anyway. I was going to ask whether you're actually capturing and managing wells operated by others where Shell's part of the partnership or something.
We do some of that, and it depends on how much we're involved in the partnership. We do manage some of those wells like they're our own if we have those rich data sets, and we have to control changes. In other cases, we would try to take that from a public source, right? So things change over time as well. One of the things we've had discussion and haven't really figured out, assets we've divested, if we go into an asset sale, we no longer have the ability to keep up the statuses for those wells. So at that point, we probably wouldn't manage them within a system like this. We'd flip something some kind of way or use a status to say, okay, now we're going to take that from the public market and leverage that because that's more up-to-date information, right? So we're still working through the mechanisms of how that could work.
Yeah, Mathieu Terris, Total Energy. I will have one question. How do you manage a single source of truth while you have several OSDU instances?
So we're still what?
You have several OSDU instances deployed. How do you manage your single source of truth and conflict management across that? What is your deployment strategy?
Yeah, so we don't, each instance, the data set's independent, right? So our Malaysia wells, for example, they're not allowed to be out of country. So they don't get replicated anywhere else. And likewise for America's wells, they don't get into the other instances. So each instance is its single version of the truth, yeah.
Thank you for sharing. Can you help us understand how do you integrate the various systems that support geoscience, drilling, and production operations with these data sets? How do you make sure that the data is live bidirectionally?
So basically, that's managed with ETL. So we're working with partners on market solutions that connect directly to OSDU. But we also, in the meantime, have ETL, so we take the data out and put it into those systems to keep that working. So we have synchronization jobs, ETLs, that run as needed into those systems. So for the subsurface community, they may not care about all 100 attributes that are in WMM, but we take the 20 or 30 attributes that are important to that community, and that could include a different flavor of well name than the wells community uses, and we sync those into those applications. But we manage them in one environment, and we try to, where we can, prevent updates and changes to those attributes in the project environment, in the subsurface projects.
Yeah, just referring to some of the data sets you mentioned, it's still early days for OSDU. We talked about at the end about leveraging the market. We are still looking and very welcoming vendors to come to us with OSDU solutions or maybe potential OSDU solutions. That's what we want to see with OSDU, right? Leverage the market. So some of your data sets we can't do yet.
Okay. Fantastic. Could you please show your appreciation? Thank you.